Welcome back. We are continuing our Solving Quadratics chapter, talking about square roots today. There are three types of solutions that are possible. If our value that we're square rooting after we use our backwards order of operations to solve is positive. That's what this greater than or equal to 0 means, that it's positive. Then we will have two solutions. If our value is equal to 0, we have one solution because the square root of 0 is 0. It's not positive or negative. There's only one answer. And then if our value under the radical is less than 0 or negative, then we have no real solutions because we don't know how to take the square root of a negative number. A reminder that we are going to use PEMDAS backwards or SADMAP to get our x alone. And then when can we use this? Well, we can use this when we are missing the b term of ax squared plus bx plus c is equal to 0. So if we're missing that b term, all we have are the x squared and the c. Then we can solve using backwards order of our operations and then taking a square root. When we personally draw a radical symbol on our paper and it's a square root, then we get two answers, a positive answer and a negative answer. And the reason for that is, let's say that we had the square root of 16. We can say the answer to that is positive or negative 4 because positive 4 squared is positive 16 and negative 4 squared is also positive 16. That's why we can have both a positive and a negative answer. So let's take a look at this. We have x squared is equal to 16. We don't have to do anything more in terms of order of operations backwards because we're already just to the square. The opposite of a square is a square root. And like we said, we have positive and negative 4 as an answer, which you can write like this, a plus or minus 4, or you can write like this, 4 and comma negative 4, whichever works best. And remember, this solution means that our x-intercepts are here at 4 and negative 4 of our parabola. X squared is equal to 0. The only thing we have to do to get x alone is get rid of the square, the opposite of a square root. A square is a square root, and the square root of 0 is 0. Remember, 0 doesn't have a positive or a negative, so we don't have to worry about two types of answers. And then for this last one, again, the x squared is alone. The only thing we have to do is get rid of the square. The opposite of a square is a square root. And square root of negative 4, we don't have to do. So this has no real solution with the negative underneath the radical. Let's see what this looks like when we do some other math. So for letter D, in order to get to just x squared, we have to move the 27 and the 3. Remember, we're doing PEMDAS backwards, which is SADMAP, so we start with subtracting or adding. We got to move that 27 over. The opposite of minus 27 is plus 27 to both sides. 3x squared is equal to 27. Divide by 3. Divide by 3. That reduces to 1x squared is equal to 9. And now we can get rid of the square by taking the square root. And we have plus or minus, and the square root of 9 is 3. So our solutions, x-intercepts, roots, zeros, are positive and negative 3. Again, you can write it as plus minus 3 or 3 comma negative 3, whichever works best for you. Letter E, we have to move this 10 over. The opposite of negative 10 is positive 10. Adding 10 to both sides, we have x squared. These add to 0 equals, these also add to 0, so we have to write down that 0. And again, the opposite of a square is a square root. Take the square root of both sides, and the square root of 0 is just 0. So our root solution, x-intercept 0, is 0. Letter F, we move with the 11 first. The opposite of a positive 11 is to subtract 11 from both sides. Negative 5x squared is equal to 5. Then we have to divide by negative 5 to get the x squared alone. That gives us a positive 1 in front of that x squared. And 5 divided by 5 is negative 1. Take the square root to undo the square, and can't take the square root of a negative here, so no real solution. You try 1, 2, and 3. Example 3, these are a little bit different because we do have adding and subtracting going on. However, there's some that are going inside the parenthesis with the square on the outside. That means that we're going to do our order of operations a little bit different. This is parentheses. So remember, if I'm talking about SADMET, backwards, we have exponents come before whatever's inside those parentheses. I have to take the square root of both sides first to undo this square right here and free that x minus 1. This is where we can write the plus or minus 5 for the square root of 5, but it might be better for us if we wrote it as positive 5 and negative 5 because we still have some math to do. In order to finish getting x alone, the opposite of subtracting 1 is adding 1. So positive 5 plus 1 is 6. Add 1, and negative 5 plus 1 is a negative 4. So we actually have two different answers this time because we had some operations after we took the square root. For letter H, if I'm again looking at, we have multiplying, we have exponents, and we have parentheses. So we have to do the multiplying first. The opposite of multiplying by 4 is dividing by 4. So these 4's reduce to 1. We're left with x minus 3 squared is equal to 9/4. You want to leave that as a fraction. The opposite of a square is a square root. That frees the x minus 3. And we have plus or minus. The square root of 9 is 3, and the square root of 4 is 2. I like to write this as two separate problems, so I don't forget the plus and the minus. We would add 3 to get x alone. 3 halves plus 3, and that would be 6 halves. So 3 plus 6 is 9 halves. Add 3, which is 6 halves, and negative 3 plus 6 is 3 halves. And so 9 halves and 3 halves are our solutions. We are going to skip down to example 4. See, we will use our backwards order of operations for this. I'm going to start with adding 13. We have 4x squared is equal to 28. Divide by 4, and we get 1x squared is equal to 7. Take the square root, plus or minus. So we have 7. 7 is not a perfect square. If I break 7 down, I get 7 and 1. I don't have anything that I can pull out to reduce that. And so plus or minus the square root of 7 is the answer. Remember, it says here, leave in reduced radical form. We don't want decimals. We want exact answers. For J, the opposite of a positive 8 is to subtract 8. That gives us x squared is equal to 11. The opposite of a square is a square root. X equals plus or minus. 11 is not a perfect square. I cannot break 11 down into anything other than 11 and 1, so I can't reduce that radical. Plus or minus the square root of 11 is the best that one's going to get. Example K, we're adding the 2 to both sides. 5x squared is equal to 2. Divide by 5 on both sides to get the x squared alone. 1x squared is equal to 2/5. Take the square root. We have x is equal to plus or minus. Well, I can't take the square root of 2. I can't take the square root of 5. I can't reduce the square root of 2, and I can't reduce the square root of 5. But remember at the very beginning of this chapter, section 9.1, we said we're not allowed to leave a radical in the denominator. And so we rationalize this by multiplying the top and the bottom by the square root of 5. On the top, I'm allowed to multiply square roots together, so 2 times 5 is 10. On the bottom, 5 times 5 is 25. I can't take the square root of 10, and I can't reduce it, but the square root of 25 on the bottom is 5. Remember, I'm not allowed to reduce the 10 and the 5 because the 10 is under a square root and the 5 is not. And so that is going to be our simplest answer. I would like you to try number 9, and we'll pick this up in class to finish off. Thank you so much. Have a great day.